Most students find adding and subtracting numbers in scientific notation more difficult than multiplying and dividing. But just like in adding and subtracting with decimals, you have to line up the decimals. So, since what we're basically doing in scientific notation is dealing with decimals, we need to make sure that the exponents are the same, because that is lining up the decimal in scientific notation. So the exponents have to be the same when we add or subtract in scientific notation. Let's try 3.7 times 10 to the 5th. Add that 3.1 times 10 to the 4th. When you get to your problem, you have to change one of these so that they match. You can either change this one to be 5 or you can change this one to be 4. My suggestion is always use the larger exponent. If you use the larger exponent, you're likely to have to change your answer into scientific notation at the end. So use the larger exponent when you're trying to decide which one to change. You want to change the smaller one to the larger one. So if I had to change this, to turn this 4 into a 5. Now, in multiplying and dividing, I mentioned that at the end you had to make sure that your answer was between 1 and 10. And if you move the decimal over here, you have to change the exponent. This is the same thing. If I change this exponent to be a 5, I have to move this decimal. Because to say that I need to move it 5 places is not true unless decimal is moved right here. Where decimal was written in green, it said move it 4 places. But if the exponent said move it 5 places, then the decimal would have to be here, because now I need to move it this place, and now I'll move it 4 places. Go ahead and add numbers together. When we add the numbers, we still have to line up the decimal. So I'm going to add 3.7 times 10 to the 5th with 0.21 times 10 to the 5th. And just like in elementary school, we can use a 0 as a filler. These are just going to stay the same because 10 to the 5th is basically a decimal. And then we're just going to go through and add like you did way back when. So I'm going to add 1, 9, the decimal goes here, and then the 3. And then we need to look and make sure that our is a number between 1 and 10, and it is. So this answer would be 3.91 times 10 to the 5th. Let's try a fraction problem. How about 9.21 times 10 to the 10th? And let's subtract 3.6 times 10 to the 5th. Now, if you remember from above, I said the best thing to do was to use the larger exponent. So I'm going to use 10 to the 7th, which means that this 5 needs to change to a 7. Well, right now, if I start at the green decimal, this is saying I need to go 5 spaces to the right. But if I really need to go 7 spaces to the right, then I need to back this up 2 spaces. So the number that I'm going to use to subtract is going to be 0.036. So now I'm going to set up the problem. 9.21 times 10 to the 7th, and then I need 0.036 times 10 to the 7th. So I'm going to fill in some zeros, just like we did in elementary school. And then remember, we're subtracting. And if you're going to miss this problem on a standardized test, it's probably because you forget that it's a subtraction problem and you add. So make sure you pay attention to the operation. This is going to stay 10 to the 7th because I'm not changing where the decimal is located. And now I just need to subtract. So if you remember however you did your rules from elementary school, this one would be 11, this now is 10. So 10 minus 6, 10 minus 3, 1 minus 0, the decimal goes there, and then 9 minus 0. And this is a number between 1 and 10, so our answer is 9.174 times 10 to the 7th.